Alright, we've been talking about functions and more specifically linear functions. Functions is a broad term. Functions mean that there's one y for every x. X's do not repeat. A linear function is a specific type of function and it makes a straight line. Now, a specific type of linear function is a direct variation, and what that means is that there is a direct relationship between an x and a y. And so, um, that would be y is equal to k times x, where k is a constant. So whatever x is, we multiply it by k, and that gives us y. And it works every single time, because that's what it means. There's a direct relationship between y and k. It'd be between y and x. If you ever are given y and x, you can divide y by x and figure out what k is. I mean, think about it here. K is being multiplied by x. So if I divide both sides by x, that gives me y divided by x is equal to k. So I can always use this to help me figure out what the constant is. And I'm sorry I sound like this, I have a cold. So alright, so you should be able to look at an equation and tell whether or not it's a direct variation by the way that the equation looks. And sometimes it's going to take a little bit of manipulating and rewriting of the equation to get it to look like y equals kx. In this particular example, we have y is equal to 3x, and this is an example of direct variation, and k is equal to 3. That's our constant. X is always being multiplied by 3 to give us our y. In this example, 3x plus y is equal to 8. When we look at it right away, it doesn't look like y is equal to kx. But what we can do is we can rewrite it and solve for y. So it says y is equal to something, and if it looks like it's in the same form, then we know that it's a direct variation. So what I'm going to do here is I've got two sides of my equation. This is like 3x is being added, so I'm going to subtract 3x. But since I subtracted 3x from here, I'm going to subtract 3x over here. And when I do that, the 3x's cancel out, leaving me with y is equal to 8 minus 3x. And because this is not in the form of y is equal to kx, this is not an example of direct variation. It's a linear function, it's just not direct variation. This example here, same thing. It's not written as y equals kx, so we're going to do a little bit of flip-flopping. And so we're going to add 4x to both sides. And when we get that, these cancel out, leaving us with 3y is equal to 4x. And so now I'm going to divide both sides by 3. And I am left with y is equal to 4/3 x. And this is an example of direct variation because our constant is 4/3. So every x is being multiplied by 4/3. This could be a fraction, a mixed number, a whole number, a decimal. It could be negative. It has to be, we can't be adding or subtracting anything over here off to the side, or multiplying by something, or dividing by something else, or, doing a whole bunch of different things. Here, we are going to, because again, it's not written as y equals kx, so we're going to subtract 3x from both sides. And so that gives us y is equal to negative 3x. And so this is an example of direct variation where our constant is negative 3. Now you should be able to look at tables and also tell whether or not there is direct variation. And what that means is every x needs to be multiplied by the same thing to get the y. So this right here each time, this example here is not an example of direct variation because there's not a constant. If you want to figure out what the constant is for each one, remember we said y divided by, sorry, I've got a cold head. Y divided by x is equal to k, and that's how we can figure out what the constant is. So for every single one of these, if I take the y and divide it by the x, I'll figure out what the k is. Well, here the k is negative 2. Here I'm going to divide y by k, 0 divided by 3, and I get 0. So because these k's are already different between these two, I know it's not direct variation. Here again, I can look, are my x's multiplied by the same thing and not? This one's multiplied by 3, this one's multiplied by 0, this one's multiplied by 3, and this one's multiplied by 2. So since there isn't a constant, there isn't direct variation. On the next one, this one is an example of direct variation because each x value is being multiplied by -4. So this is an example of direct variation. And this one here, this is not direct variation because each x is not being multiplied by the same thing. Now, sometimes you're going to be asked to find the constant of variation to help you solve for another variable. So what I mean by that is, this says the value of y varies directly with x. So what that means is it's telling you that this is a direct variation. Y is equal to kx. Okay? Now, what it does say, too, is it's saying, well, if y is 3, when x is 9, use that to help you figure out y, what it's equal to if x is equal to 21. So what I can do is if I know that y is 3 when x is 9, I can use that to help me solve for k. So I'm going to divide both sides by 9 here to solve for k, and I get that 1/3 is equal to k. So for this particular example, my constant is 1/3. So I'm going to plug that all the way in right here and say, well, what is y? My constant's 1/3 if x is 21. Well, 1/3 of 21 means 21 divided by 3, which is 7. So for this particular example, y is equal to 7. All right, let me do one more. Again, this one is saying that y varies directly with x, so that means this is direct variation. Y is equal to kx. And y is equal to 4.5. We don't know what k is, but we know that x is equal to 0.5. So it's saying find y when x is equal to 10. Y equals kx. So I'm going to solve this here. I'm going to figure out what k is. I'm going to divide both sides by 0.5. This cancels out, so I get that 9 is equal to k. Oops, sorry. So I'm going to come up here and replace k with 9. So y is equal to 9 times 10, which is 90. So y is equal to 90.